Welcome. Today we will delve into the secrets of one of the most significant technological breakthroughs of World War II. How the American P-47 Thunderbolt fighter became a symbol not only of military strength, but also of industrial superiority that determined the outcome of the conflict. But what lies behind its sleek fuselage and powerful engine? Why did German command ignore the obvious signs of a technological gap? And what does this mean for the entire course of the war? Behind a single captured aircraft and its unique technical solutions lies an entire era, an era where the scale of production and engineering ingenuity defined the victor. Could this technological onslaught have been stopped, or was Germany doomed, ignoring reality? If one aircraft can reveal the depth of the industrial gap, what else is hidden behind the closed doors of German industry, and how does it influence the outcome of the war? In this video, we will unravel the mystery of American superiority and show why ignoring facts led Germany to catastrophe. Are you ready to see what is hidden in the archives? Then let's begin. In August 1943, when the war had already become a grueling struggle of attrition, when Europe's fate hung in the balance and hopes for a quick victory were thinly stretched like a tightrope, German engineers and pilots found themselves on the verge of a new, unprecedented discovery. At that time, on a remote Luftwaffe airfield in the French rear, in the shadow of trees and under the roar of heavy engines, a meeting took place that forever changed perceptions of technological superiority and the power that the United States could demonstrate. Among wrecked and captured aircraft, amid debris and evidence of combat encounters, the American fighter first appeared as if from another world, the P-47 Thunderbolt. This aircraft, like a chunk of steel and innovation, was brought to a German base after a fierce fight in which the American pilot was taken prisoner and his plane remained almost intact, a miracle from the realm of technical wonders. Reports of its capabilities, which began spreading among German circles, seemed unbelievable. German pilots, accustomed to their own equipment, their aircraft, their tactics, first heard of a machine capable of doing what their own technologies seemed unable to replicate. They spoke of the P-47 not as just a huge, clumsy machine, as initially assumed, not as a phlegm or milk bottle design, as it was considered in the first hours after capture. No, it was something else. It was a testament to an era that was about to end. It turns out that appearance is only a facade, a deceptive mirror of inner power. Inside this giant, engineers' solutions, tactical advantages, and industrial might were hidden, indicating that the USA did not just possess technology, they had created a new era. This aircraft, with its unique structure, capable of striking from long distances, with unpredictable maneuverability and endurance, became a symbol of America's industrial capabilities, their ability to mobilize resources that Germany seemingly neither had nor could have. It became a living proof that American industry was far ahead, that their technological gap was not just microscopic, it was enormous. These facts, these pieces of evidence, which at first glance seemed insignificant or even unreliable, began to raise alarm among the German command. But a quick question arose. How should they respond? Can these pieces of evidence be ignored? Can the proof of technological superiority be dismissed? Within the German leadership, among military engineers and strategists, a duality took hold. Some saw this merely as another propaganda message, possibly caused by American pilots' disappointment or demoralization. Others began to realize that there was something more behind it, that it was not just a coincidence, not just luck, but a systemic breakthrough that could change the course of the war. Ignoring these facts would be a strategic mistake that could cost Germany everything. After all, considering the scale of the U.S. industrial potential, it becomes clear. This is not just another aircraft, but a symbol of an entire era. The power of American industry, their ability to produce thousands of such machines, their innovative technologies and systematic implementation. All of this makes them a force capable of turning the tide of the war. It is no coincidence that, at a time when German industry was suffocating under the weight of military orders and resources were running out, American enterprises were operating at double capacity, creating new technological samples that seemed fantastic. Their industrial capabilities became increasingly evident, more dominant. Nevertheless, deep inside German offices, a sense of uncertainty reigned. Official propaganda and engineers' reports were often ignored or met with suspicion. Some commanders believed these messages were merely speculation, demoralizing rumors fueled by American propaganda or intimidation. They inclined to think that German equipment, even if inferior in some parameters, still surpassed American developments. But the facts told a different story. The evidence is irrefutable. The American aircraft is not just a machine, it is a symbol of the technological and industrial gap that could determine the outcome of the war. And so, against the backdrop of these events, the main question of this chapter arises. Can one ignore, or worse, reject the obvious technological superiority of the USA based on outdated notions, ideological prejudices, and habits of their own equipment? What does this mean for Germany's strategy? Is defeat possible if the true picture is not acknowledged? If one fails to realize that behind the closed doors of American industry lie achievements capable of rendering any German aircraft obsolete overnight? The answer is obvious. Ignoring the facts is a path to defeat. The longer the German leadership clings to its illusions, the faster it will find itself trapped in a situation from which there is no escape. If a single aircraft can reveal the full extent of the industrial gap, what else is hidden behind the closed doors of American factories, behind the walls of their research centers? What more have these engineers and scientists prepared for them? What secrets, what technological breakthroughs await to change the course of the war? These questions are relentless. They are like a shadow constantly reminding us. Behind the outward calm, behind the apparent equality, a war of technologies is hidden, one that determines the fate of millions. And if one aircraft was able to show the whole world, and especially the enemy, that America is a step ahead, what else could be concealed behind those doors? What other secrets, what further achievements might be hidden from the enemy's eyes? This story is not just about a technical marvel or a specific aircraft. It is about scale, industrial power, strategic superiority that shapes the very outcome of the war. And if one aircraft can open the world's eyes, what else is hidden behind the closed doors of German industry and scientific laboratories? What does this mean for the fate of Europe as a whole? What consequences, for Germany, for the world, does this technological gap carry? After all, if one aircraft can tell so much, what else remains behind its wings? What secrets are hidden behind the glass of German eyes, behind the walls of their factories? And what does this say about the future, which is already not so far away? In the mid-1940s, when the sky became the arena of the fiercest battles, when every second could decide the fate of the entire war, American aviation industry created something truly unique, an engine that became the heart of a legendary fighter capable of changing the course of aerial combat. It was not just an engine, it was an engineering miracle, an embodiment of scientific thought, where every detail spoke of American superiority and technological might. And it is precisely its design, features, and unique engineering solutions that help explain why the American P-47 became one of the most formidable and effective fighters of its time. The discovery of this engine was a real sensation. The power declared in official documents could not leave anyone interested in aircraft manufacturing indifferent. It had at least 2,000 horsepower, which was 30 to 40% more than German counterparts, BMW 801, and other engines with which German fighters competed in aerial duels. This difference in power was not just a number. It was a fact that determined the outcome of battles. In the air, the American P-47 equipped with this engine could maintain superiority, stay engaged at altitudes where German fighters were already beginning to lose effectiveness, and even surpass their opponents in speed and maneuverability. Majestic and powerful, it seemed to embody the spirit of American industrial might, ready for any challenge. But behind this figure lay an entire era of engineering solutions, inaccessible to German designers. The entire engine construction was built with exceptional precision. Each component, every joint, and every surface was made from high-quality alloys, specially developed to withstand extreme loads and temperatures. There were no signs of compromises, which were often found in German engines, where cost-saving measures and limited resources led to reduced lifespan and reliability. American industry understood that only absolute precision and the use of the best materials could ensure long service life and stable operation of the engine under the most demanding conditions. A special place was occupied by the cooling system and the technical design of the cylinders and cylinder heads. Each cylinder head could be replaced individually and quickly, a revolutionary solution that significantly reduced repair and maintenance time. Such modularity was absent in German aircraft engines, where any intervention involved long downtimes and complex repair procedures. American engineers created an engine that could be fixed, literally on the fly, replacing individual cylinders or components without disassembling the entire unit. This was a crucial factor determining the fighter's combat capability during prolonged operations, where every minute could cost the pilot's life. A major achievement was the turbo-supercharger system. This modern, complex mechanism used exhaust gases to spin a turbine, maintaining engine power at high altitudes. In aerial combat conditions, where altitude often reached 25,000 feet and higher, German fighters lost much of their capabilities. Their engines became less efficient, lost power, and consequently, combat effectiveness. In contrast, the American P-47 with a turbo-supercharger system could preserve its power, remain at peak efficiency, and fight effectively at high altitudes where German pilots could no longer compete. This was not just a technical innovation. It was a new milestone in aviation engineering, a solution that changed the rules of the game. The design of this system included extremely durable materials capable of withstanding the temperature and pressure generated during operation. Precise engineering, complex mechanisms, perfectly matched components. All of this made the system reliable and long-lasting. German enterprises could not replicate such systems. Their technological level and industrial base did not allow for the mass implementation of such complex and precise systems. In Germany, where military production was limited by resources and technological progress was slower, such a system seemed an unattainable dream. Could a similar system be reproduced in Germany? That is a philosophical question. Analysis shows that despite its achievements, German industry faced limitations in material science, metal processing technology, and production scale. Creating such a system would have required not only new technologies, but also fundamental changes in production organization and, most importantly, in scientific approach. During wartime, when resources and time were limited, reproducing such complexity was practically impossible. American experience and scale of production proved decisive. Their industrial base, unified within a militarist strategy, allowed them to realize the most daring engineering ideas. Development, testing, and deployment all took place in enormous factories where every screw, every part mattered. And it is precisely this that explains why the American engine was not just a technical marvel, but a manifestation of systemic superiority, capable of ensuring dominance in the sky. The central question of this narrative is whether the German conglomerate, despite all its achievements, could have reproduced such complexity. Could it have created systems comparable in technological difficulty and reliability to the American ones? And if the answer is no, what does that mean for the outcome of aerial combat, for the fate of the skies, and for the balance of power on the fronts? These are questions that remain without a definitive answer, but their solutions lie in facts, evidence, and analysis of the capabilities both sides possessed. If the power and technological complexity of American engines are just the tip of the iceberg, then how could German engineers contend with this superiority? What strategies, technical and tactical solutions could have leveled this technological gap? Was it even possible for military art, despite all its cunning, to overcome such a technological chasm? Or did this very gap become the key factor determining the outcome of air battles? These questions, requiring deep reflection and analysis, lead to one conclusion: the true strength of engineering thought and its role in war. So, having examined the technical details and delved into the complex world of engineering solutions and technological superiority, we ask ourselves, where are the limits of human genius? And most importantly, what if German industry could, in theory, reproduce or even surpass these systems? And if the answer is no, what is the cost of that? The cost of technological backwardness, the cost of defeat in the air, a price that reflected in the fates of millions. These questions continue to haunt us. They make us think about how science, industry, and military art are intertwined in decisive battles. Because technology is one of the key factors determining victory or defeat, this chapter is not just a story about an engine, but a testament to how engineering thought can become a weapon capable of changing the course of history, determining the outcome of a war, and leaving a lasting mark on humanity's memory. In the vast and brutal war, where every second of flight could be the last, survival became not just a desire, but the only way to accomplish one's mission and return home. It was in this context that something phenomenal appeared among many aircraft, a fighter that could become a symbol of invincibility. Its name was P-47, a mighty American tank in the air, a legend that transcended technological boundaries and became an embodiment of combat resilience. But what exactly made it so? How can its unique ability to continue fighting, even after being hit by numerous shells, as if struck by the cores of hell, destroying its fuselage, damaging its wings, and wrecking its structure, be explained? What secrets lay behind its massive construction, its internal design, and the philosophy behind its creation? This chapter is not just a description of technical specifications. It is a deep dive into the very essence of reliability, into the spirit of a combat machine that proved to be much more than just a means of destroying the enemy. Perhaps the most striking and convincing fact is the phenomenal resistance of the aircraft itself to damage. During numerous combat tests and sorties, pilots recorded astonishing cases. An aircraft that was hit directly by a 20mm shell, of which there were many, did not simply withstand the impact. It continued to fly. In some cases, damage was limited to external parts. Wings creaked, broken panels flew off to the sides, but the internal frame and engine remained intact. In others, more critical components were damaged. Several engine cylinders burned out, fuel tanks seemed shattered, yet the aircraft, like a living creature, continued to stay in the air, fighting against its fate, inching closer to the base with each meter. Such accounts were not isolated. They confirmed that the design of the P-47 was created not just for flight, but for survival. The main secret lay in its construction. A thick aluminum fuselage, like tank armor, covered the internal structures. Reinforced frame, specially designed to absorb shocks, and a protected cockpit. All of this transformed the aircraft into more than just a flying machine. It was a tank in the air, capable of withstanding what would be a deadly blow for others. Despite damage, internal systems continued to operate thanks to high-quality armor and engineering solutions. Pilots' testimonies confirmed that even when several engine cylinders were destroyed and fuel tanks damaged, the aircraft remained controllable. It continued flying, returning to base, sometimes with difficulty, sometimes with noticeable damage, but always alive. And importantly, it was always ready for a new fight. This raises the question, could German engineers, the creators of German fighters, have ensured the same level of survivability? Their technological arsenal undoubtedly included high-tech solutions, lighter constructions, and more maneuverable aircraft. But did they ever create a flying tank, an invulnerable combat machine? Their concept, to be faster, more maneuverable, and more elegant, contradicted the idea of heavy armor and the ability to survive hits. While American engineers added layer after layer of metal, creating something essentially impervious armor, German approaches leaned toward lightness and speed. But this strategy, reducing weight and abandoning heavy protective elements, made them more vulnerable in critical situations. Could a vulnerable yet fast and maneuverable aircraft be created that, upon damage, simply lost combat capability? Or, as the facts show, the concept of over-engineering, adding weight and reinforcing structures for reliability, became the key to success and survival in the most intense battles. This question goes beyond technology. It concerns the very idea of combat resilience. In wartime, where every second and every shell can decide the outcome, there is a sense that massiveness and reliability provide an advantage. The internal systems of the P-47, its armor and construction, all are the highest results of engineering analysis, meticulous work, and a bold idea that proved victorious. Pilot testimonies are living proof. Even in the most critical situations, when it seemed all was lost, the aircraft continued to fight, to fly, to perform its mission. And this is no coincidence. It is the result of design that considered all possible scenarios, all potential damage, and all threats. The main question hanging over this story is, could German engineers, even if they wanted to, achieve the same resilience and survivability without a radical reworking of their concept? They had technology capable of matching American aircraft in speed and maneuverability, but could it have become equally invulnerable? Could a lighter, faster plane have been created that could continue fighting after being blown to pieces? Analysis suggests that, most likely, no, because the very philosophy of German fighter design was a strategy for a lighter, faster aircraft, not a tank in the sky. And perhaps this very difference was the decisive factor. Ultimately, an obvious conclusion emerges. The concept of over-engineering, adding weight and reinforcing the structure for greater durability, proved to be not just a technical choice, but a strategic advantage. Despite its excessive mass, this principle allowed the American fighter to become a symbol of invincibility. It demonstrated that in war, speed and agility are not always the most important. Sometimes, the ability to withstand a blow and continue fighting matters more. This became a lesson that forever changed the approach to designing combat aircraft. If America creates a, quote, flying tank, then how can Germany compete under such conditions? The question is not only about technology, but also about philosophy, strategy, and understanding the very essence of a combat machine. Time has shown that in the battle for the skies, in the confrontation of ideas and technologies, it is mass and reliability that prove to be key. And this lesson is not just about iron and metal. It is about spirit, faith in one's concept, and the determination to perfect every detail. That is the core meaning. In a world where defeats and victories are decided by millimeters and milliseconds, survival and the ability to resist damage become the true measures of strength. In this race for superiority, in this battle for the sky, the American P-47 became not just a prototype of reliability, it became a symbol of resilience, which continues to live in memory as an example that sometimes it is precisely over-engineering that holds the key to victory. In the early 1940s, when the world plunged into the chaos of global war, aviation technology was advancing at an incredible pace. On the front lines of the battle for the skies, where fate depended on the tiniest details, one of the most powerful and formidable weapons was the American P-47 Thunderbolt fighter. Its appearance was no coincidence. It was the result of meticulous engineering solutions, carefully thought out to ensure dominance in aerial combat. Among its many features, one stood out: the incredible firepower capable of striking the enemy with astonishing efficiency. This power was not just a weapon. It became a symbol of technical genius, a tool capable of changing the course of a battle, destroying any enemy plans, and annihilating any hopes of survival in the air. The armament of the P-47 was not just a set of machine guns. It was power embedded in a metal frame, capable of firing over 100 rounds per second. 8 heavy 12.7mm Browning M2 machine guns, each with 400 rounds, created a deadly storm. Imagine, every second, Every minute of combat, hundreds of shots, hundreds of bullets, each filled with destructive energy. In total, over 32,000 rounds ready to destroy any aircraft. This ammunition supply was not limited to short bursts or small reserves. It was an endless stream of deadly projectiles, prepared at any moment to turn the enemy into a heap of metal and debris. Rate of fire is not just a number. It is the living breath of a combat machine. More than 100 shots per second is almost a continuous stream of fire, turning the sky into a battlefield where every shot is a blow of fate. Such fire gave the pilot a unique opportunity to provide almost constant gunfire support, leaving the enemy no chance to evade. During a short burst, about 200 rounds, any German aircraft instantly became a target that lost its combat capability in an instant. Whether it was a small attack armament or a heavy bomber, the power of the P-47 was so great that destruction was achieved in mere moments. But the main point is that, unlike German aircraft often equipped with limited ammunition, the American Thunderbolt could fight longer without running out of bullets. Its systems were designed so as not to restrict the pilot in providing fire support. He could shoot as long as there were rounds, without worrying about reserves. This advantage in prolonged aerial battles, where every second counts, became decisive. The high mass and energy of the bullets allowed them to pierce the armor of German planes, destroying their structures and systems. In an instant, machine gun bursts turned aerial combat into a bloody show of destruction. And here arises the question: could German pilots withstand such fire? Could they, with only limited resources, endure the storm unleashed by the P-47? The answer is obvious: no. The evidence is irrefutable. German air forces, even the most prepared and well-equipped, could not withstand such an onslaught without losses. Their aircraft, designed for quick fights and short raids, lacked both the speed and firepower of the P-47. They were vulnerable, like targets under a hail of fire that left them no chance to respond. And the engineering solutions embedded in the P-47 transformed it into a weaponized machine, something more than just a fighter. It was an engineering marvel, embodied in metal, a machine capable of destroying the enemy with cold precision, driving those who tried to oppose it mad. It was this power that made the P-47 a versatile weapon, capable of determining the outcome of battles. Its machine gun systems, the result of brilliant engineering, were not just means of shooting. They became a weapon that destroys any enemy plans, turning air combat into a demonstration of superiority. Every bullet is proof that technology can surpass human weakness and fear. This weapon was created to overcome any obstacle, destroy any target, and forever change the rules of the game in the sky. And now the main question arises: can such armament compare to the capabilities of German aircraft? Can German systems, even the most modern, compete with this avalanche of fire, this power, this continuous stream of deadly bullets? The answer seems clear. German aircraft, although of high technical level, could not fight against this monster. Their armament was limited, their speed not so high, and their armor weaker. As a result, all attempts to withstand American fire inevitably ended in losses. And while one aircraft could literally, quote, break through the enemy's defenses, how should the tactics of German pilots have changed? How could they fight against such power that literally destroys everything in its path? If one aircraft is capable of piercing any barriers, destroying the enemy with such precision and speed, then the logical conclusion is that tactics had to change radically. Perhaps new ways of evading, new forms of protection, and new strategies needed to be developed. But one thing was clear: the American Thunderbolt, with its incredible firepower, not only changed the rules of air combat, but also questioned the entire concept of aerial confrontation. And this, the essence of the great struggle that unfolded in the skies during the war, was a battle in which technology and strategy constantly opposed each other, changing and evolving to ultimately determine the outcome of the great conflict. Could German systems match this formidable weapon? A question for which there is no definitive answer. But one thing is clear: In a world where one aircraft can, quote, break through enemy defenses, change the course of a battle, and turn the airspace into a field of triumph, any tactics had to evolve. And this story, a tale of power and engineering brilliance, of the fight for dominance in the sky, continues to serve as a reminder. In war, as in any other sphere, superiority is achieved not only through numbers or capabilities, but also through skill, innovation, and the courage to venture into the unknown. The greatness of American industry during World War II was not merely a technical achievement or a result of organizational efficiency. It was a colossal, virtually inexhaustible mechanism that in its power surpassed everything Germany could have imagined in its most ambitious dreams. Every system, every detail, every component reflected the vast potential of a country that, unlike Germany, built its military machine on the basis of unstoppable industrial strength, advanced technologies, and colossal resources. And it was this power that became the impregnable wall which the Germans could never overcome. All the P-47 systems, which we now regard as examples of engineering excellence, are the result not just of the work of individual engineers or designers. They represent the pinnacle of an entire industrial era, when the production of engines, turbochargers, armament, and armor required not only advanced materials, but also precise technological execution. Titanium alloys, lightweight aluminum alloys, high-strength magnesium components. All of this could not have been produced in Germany on such a scale and with such precision. Production was organized so that each link in the chain operated with maximum synchronization, minimizing defects and enhancing quality. It is no surprise that American industrial potential during the war exceeded all expectations. Let's recall the figures, immeasurable in their significance. Over the course of the conflict, more than 125,000 R-2800 engines were produced, surpassing all German benchmarks in both scale and efficiency throughout the entire war. Although the Germans possessed advanced technologies and implemented innovative solutions, they could not approach such levels of mass production. Their factories, despite efforts, could not ensure the same speed and quality of output. In 1943, at the height of the war, American industry was producing over 80,000 aircraft per year, a number that is astonishing in itself. Moreover, these aircraft were heavier, more complex, and more powerful than their German counterparts. They carried not only weapons and armor, but also symbolized America's might and technological superiority. Meanwhile, Germany, despite its technological achievements, could produce only about 25,000 aircraft annually, and that was at significantly smaller scales. Operational capacity and production speed were what determined the outcome of the air and ground battles. What lies behind this gap? The answer is obvious. The entire industrial might of the United States was mobilized for the war. Car factories, which in peacetime assembled automobiles, were converted to produce aircraft engines. Shipyards turned into factories for aircraft fuselages. Every factory, every workshop, every assembly line was tuned for mass production. It was not merely an increase in capacity, it was the creation of a new industrial reality, where every part, every screw, every nut was manufactured with impeccable precision and on a massive scale. The scale of production is not only about numbers, it is about quality, achieved through continuous technological and process improvements. America built a system capable of ensuring stability and reliability, even at such colossal volumes. And it was precisely this quality and scale that made it impossible for Germany to imitate such a level of mass and high-quality production. The industrial gap between the two countries was not just a technological disparity, it was a vast, insurmountable barrier that could only be crossed by those possessing enormous resources and power. The logical question arises, could German enterprises ever reach such a level? The answer is clear. No, they could not. All infrastructure, technological supply chains, and resources were so limited that even with the strongest desire, Germany could not surpass American industrial might. Despite its innovations and technological achievements, German industry remained internally constrained. The gap was not only in technologies but also in scale and resources. It was an invisible but very tangible chasm that determined the course of the war. This industrial disparity became the main factor shaping the outcome of the conflict. Part 12 of 17. When one country is capable of producing hundreds of times more and much better, it not only dominates on the battlefield, but also dictates its terms to the entire world. The United States didn't just win battles. They created a machine unmatched by any other. Their industrial might became a weapon capable of crushing any opponent, even when the latter had technical advantages. Yet, a question arises. What if Germany had been able to approach American-scale production? What would that have meant for the war? The answer is obvious. If German industry had been able to produce at similar volumes and quality, the outcome of the war might have been different. German aircraft, weapons, and equipment could have competed not only in effectiveness, but also in quantity. Battles on the fronts could have taken a different course, and perhaps Germany could have achieved a strategic advantage. But reality shows that this was nearly impossible. The barrier built over centuries of industrial development, technological limitations, and resource constraints was insurmountable. This industrial gap was not only a symbol of one country's capability versus another's incapacity. It was a testament to how scale, organizational strength, and technological maturity turn war into a struggle not only of weapons, but also of the resources behind those weapons. America, which at the beginning of the conflict seemed just one of the great powers, transformed into an invincible industrial machine. And this was a decisive factor in its victory. Ultimately, if industrial superiority is the key to victory, then why did Germany, despite all its technological achievements, continue to ignore these facts? Why did it rely so heavily on tactics, willpower, cunning, and strategic maneuvers when all evidence pointed to the fact that without massive resources and an industrial giant, victory was impossible? This question remains open. But one thing is clear. In a war where the decisive factor is not only soldiers and tactics, but also industrial capacity, an emphasis on willpower and tactical tricks was merely an attempt to compensate for what was essentially impossible to equalize. It was this struggle for industrial supremacy that became the key factor, determining not only the course of the war, but also the fate of the world in the post-war years. In an era when the darkness of war covered Europe and the fate of the world hung by a thin thread, the leadership of the Third Reich received many signals, alarming, clear, and unequivocal. These signals came from the very technological and industrial heart of the New World, the United States of America. It seems simple. Americans demonstrated their achievements. Their engineers presented facts, numerical indicators, and evidence of unconditional superiority. But despite this, the German command rejected these reports, seemingly unwilling to face the truth that could have changed the course of history. It was not merely a refusal to accept the facts. It was an act of conscious ignorance, a strategic blindness that ultimately led to catastrophe. In 1944, as the war reached its bloodiest and most brutal stages, the Third Reich's intelligence provided the leadership with undeniable evidence. American industry had reached new heights. Their technology outpaced German weaponry, and their production capacities had grown to levels Germany could only dream of. And what did the German leadership do? They continued to receive these reports, listened to them, analyzed them, but rejected them. Why? Perhaps because acknowledging them would mean admitting weakness. Perhaps because faith in the invincibility of the army and the heroism of soldiers was stronger than any analysis. Or, more all-consuming, political and ideological belief in the invincibility of the Führer, in the exceptionalism of the German race, in the power of their technology. Time went on, and each new report, each new warning seemed to the leadership just noise, a background to their confidence that everything was under control. However, within engineering and strategic circles, other opinions whispered. Werner Schulz, one of the leading engineers, a man whose voice was based on facts, technology, and analytical thinking, reached a unanimous conclusion. Germany could not win the industrial war. His words were clear, direct, unadorned. He saw that the enemy's resources, technology, and production capacities were growing at a frightening pace, while ours lagged behind. He wrote reports that, in essence, were diagnoses of a deadly disease. If tactics were not changed, production reoriented, and the true situation recognized, defeat was inevitable. But these reports were ignored. Not because they were unfounded or mistaken, but because their authors were perceived as carriers of insufficient combat morale or propagandist demoralization. And here arises a question. Why did the High Command, the people responsible for the fate of millions, reject the obvious facts? Why did they prefer to see only what they wanted to see? Heroic battles, heroic heroes, heroic resilience. Wasn't it obvious that the technological and industrial advantage of the enemy was in full swing? What was their faith based on? Political will, ideology, personal confidence, or fear of losing power, admitting mistakes, recognizing that everything was built on illusions? Perhaps they sought excuses for their actions, or simply feared admitting that the war was already lost, that even the bravest soldier could not win against technological superiority that could not be stopped. It was this systemic blindness, the refusal to face reality, that became the main cause of defeat. Germany continued to fight despite compelling and irrefutable evidence that the enemy was surpassing it in all key areas. They believed in heroism, in weapons, in fighting spirit, and at the same time ignored the technological revolution that was changing the rules of the game. This faith, this determination, which could have become their strength, turned into shackles, preventing them from seeing the truth. The truth that victory was impossible without considering and adapting to new conditions. Could Germany have changed its strategy? Could it have believed in the facts that were obvious to many engineers and strategists? In those rare moments when someone from the leadership asked themselves this question, the answer seemed obvious. But political will and ideological belief in invincibility prevented them from making the right decision. Time was passing, and every day of delay, every missed opportunity, brought them closer to inevitable collapse. Ultimately, the systemic ignoring of facts, the refusal to listen to reality, this is the reason why Germany was defeated. It was not heroism or lack of tactics, but precisely this blindness, this faith in illusions, that proved fatal. And here arises the final profound question. If even the most intelligent engineers, analysts, and strategists understood that defeat was inevitable, what kept them in this collective delusion? What was the role of ideology, political will, personal ambitions in their refusal to see the obvious? Perhaps it was faith in a higher power, in fate, in Germany's historical mission, that prevented them from accepting the simple but harsh truth. Or perhaps it was the result of strict control and fear of the consequences of admitting mistakes. Ultimately, history shows that ignoring facts is not just a tactical or strategic error. It is a tragedy fueled by blind faith, illusions, and a refusal to accept reality. And the consequences of this tragedy, defeat, determined the fate of the world. The world we live in today is the result not only of political decisions and strategic alliances, but also of the relentless development of industry and technology. During the Second World War, which shook the entire world, these factors played a decisive role. And if we look closely at the historical facts, it becomes clear. Victory or defeat is not only a matter of tactics or heroic deeds. It is the result of large-scale industrial and technological battles, in which one side had an incomparable advantage. In these conditions, when the fates of millions were decided on production lines, lessons emerged that are still relevant today. They show that ignoring the technological gap is playing with fire, and neglecting industrial power is risking one's own future. The Allied victory in the bloodiest war of the 20th century was determined not only by strategy or heroism, but also by enormous industrial potential. Let's look at the facts. During the war years, American industry became the backbone of victory. Museums and archives hold hundreds of thousands of documentary evidence. More than 300,000 aircraft were assembled in the United States, more than twice the total number of planes produced by Nazi Germany throughout the war. Among them were the legendary P-47s, powerful, durable, capable of destroying any enemy aircraft or ground target. Over 15,000 of these were produced, and the engines, the heart of any aircraft, represented both a tragedy and a triumph of engineering. The most mass-produced was the R-2800 engine, which was manufactured and installed in millions of planes. These facts are not just numbers. They are a testament to an unprecedented industrial might that could supply the front with everything necessary, avoiding shortages and halts in production. Germany, on the other hand, produced about 94,000 aircraft during the entire war. This is less than a third of the American output. And not only in terms of quantity, in quality, these machines lagged behind American ones in many parameters, from speed and maneuverability to range and reliability. German industry, which at the beginning of the war seemed limitless, faced harsh reality. American industrial superiority was undeniable. Their factories, large engineering corporations, and automotive giants were all repurposed for military needs. The era when cars were primarily a means of personal mobility gave way to vast workshops producing aircraft, engines, and armaments. The entire American industrial complex was mobilized, transforming into a unified mechanism geared toward victory. And this mobilization was not just a fact but a lesson. In an age of technological competition, military dominance is achieved precisely through large-scale, coordinated efforts. Conversely, German leadership lost not only tactically. Their defeat was driven by much deeper reasons, primarily their inability to adapt to technological demands of the time. Their failure to understand that without industrial superiority, victory was impossible. The main lesson lies here. Reliance solely on willpower, ideology, and strategy leads to defeat. Modern historians and archival documents show that German engineers and scientists were often underestimated or ignored. Their warnings about the need to develop new technologies went unheeded. Time has shown that victory in war is won not only on the battlefield but also in factories, on production lines, and in laboratories. The moral of this lesson is simple and clear. Ignoring facts and scientific data, relying only on will and ideology, leads to catastrophe. Could the tragedy have been avoided if German leadership had listened to engineers? These questions remain relevant today. Analysis suggests that many losses could have been prevented if the right decisions had been made in time. If German engineers had been given the opportunity to implement new ideas, and intelligence had provided timely and accurate data on the Allies' superiority, the outcome of the war could have been different. But fear, bureaucracy, and reluctance to change established schemes all played their part. Still, the final result is clear. The technological and industrial gap became a decisive factor that determined the victory of the United States and the defeat of Germany. This is not only a lesson of history, but also a sobering warning for the present. These facts, these proofs, these lessons are not just historical details. They shape our modernity, our strategy, our priorities. The question that looms over everyone is, can we, as a modern society, learn from the past? Can our states, corporations, and scientists understand that without technological superiority and strong industrial foundations, victory is impossible? After all, if one war showed that industrial dominance determines the outcome of a battle, current events confirm that competition in technology, innovation, and digital solutions is becoming the new battlefield. Today, the fight is not only for resources or territories, it is for minds, knowledge, and the infrastructure of the future. If in the past industrial superiority was the key to victory, today it is no less important, and perhaps even more critical. In the era of digital technologies, artificial intelligence, and quantum computing, the same principles remain relevant. Whoever masters the latest technologies first will win the race for the future. And if we fail to learn lessons from history, if we do not understand that ignoring technological aspects means condemning ourselves to defeat, we risk repeating the tragedy of the past in a new, more complex, and more dangerous form. Because ultimately, history teaches us that technological development is not only progress and comfort, but also a tool capable of shifting the balance of power. The winner in this new war will be the one who more quickly, more intelligently, and more efficiently exploits the opportunities of industrial and technological superiority. This is the main conclusion that should remain in everyone's memory. In this struggle for the future, for dominance, and for technological sovereignty, the main emphasis is placed on industry, innovation, and science. And as history shows, the losers are those who underestimated the power of the industrial gap, who failed or refused to invest in technological development. These lessons are not only for historians or politicians, they are for everyone, because victory or defeat in the future will depend not only on military strength or diplomacy, but also on how prepared we are to invest in technology, how quickly we learn to recognize dangers and opportunities, and how swiftly we can mobilize our industrial potential. And in this lies the main meaning and the greatest challenge of our time. In the times when a single war demonstrated that industrial superiority determines the outcome, today we see that this truth remains unchanged. The only difference lies in the scale and forms. Battles are fought in digital spaces, laboratories, and on the production lines of the future. Those who ignore this fact today risk being left behind in a history that relentlessly moves forward toward new technological heights and new battles for the future.